Very good. So in this course, we're going to talk about different types of angles. Well, what is an angle? When we're talking about an angle, we are doing the following. We start by taking a point and we call it the vertex. Okay, here we have the vertex and we have a very small ray or a small arrow. This is my ray, this is my small arrow. Starting from this vertex or the starting point. Then I start rotating, start taking this small arrow, small ray, and start rotating this counterclockwise. So this is the direction that you're taking, counterclockwise. Counterclockwise. Well, this ray, for example, stops at this position. Stop at this position. We call this the initial position. The initial position. And at this location, we call it the terminal position. Terminal position. Well, this counterclockwise rotation creates an angle here. We just created something new that we call angle, like theta. We usually denote angles by Greek letters, alpha, beta, theta. So theta is an angle. So this is the creation of an angle. Then mathematician thought, well, since we have XY plane, why not using the XY plane and put the initial position on the positive part of x-axis? They say that, well, to create an angle that we all mathematicians, all people who study math have the common starting point definition. Let's define it this way. You say that to create an angle, we use XY plane. Okay. They put the vertex on the origin. We use the origin as the vertex. So we use the positive part of x-axis as the initial position. Initial position. Okay, so far so good. These are the conditions that will help us to create an angle, and everybody around the world has the same and common language about that. So here you have x-axis, horizontal axis, then you have your vertical axis, y-axis. This is my vertex located at the origin. This is my vertex. And my initial position is going to be on the positive side of x-axis. Initial position. Okay, so we start taking this ray and start rotating this counterclockwise. Counterclockwise. You can just go around, and just start rotating as many times as you want. But this is not our intention. Our intention is to take this and just stop, for example, here, create one angle and rotate it here, create another angle, and talk about different methods of measuring that angle. What is the measurement of that angle? What is it, that angle? So the initial position, and start counterclockwise rotation, counterclockwise or rotation. Counterclockwise rotation. And suppose your ray stops here. I took this guy and I start rotating this. And suppose I'm stopping here. We call this the terminal position of the same ray. This is the same ray like the clock. This is my terminal position. Terminal position. So we are creating an angle, theta, alpha, beta, and it is a positive angle. If you use not the counterclockwise, just the clockwise rotation, you're going to get a negative angle. So theta is my angle. Now the question that you should be asking, how do I measure this angle? Now that we've defined this new mathematical object, the question is how to measure it. So there are different ways measuring an angle. Two popular ones are using the radian and the degree. We use two popular methods measuring an angle, using radian and also the degree. When you're using your calculator can be set up into radian mode, or it can be set up into degree mode. Our goal is to define the radian measurement and the degree measurement for an angle like theta. Okay, so now that we talked about an angle and different methods of measuring an angle, let's define them separately. Let's first define the radian definition. Definition of radian. So 1 radian is the measure of some central angle whose arc length is the same as its radius. What? 1 radian is the measure of central angle whose arc length is the same as its radius. Let us analyze this definition. Okay. Remember how we built an angle. Okay. I see an angle. I see the initial position, I see the terminal position, and I have this ray or arrow that moves counterclockwise. Let us take a look at this. If I just take this piece of pie and just graph it exactly here. This is my initial position. This is my vector. This is my arrow that you have here in its initial position. And I move this counterclockwise, and this is my terminal position. Am I right? I have a piece of pie. This is my pie. Okay, very good. So far, everything looks delicious. I have my theta here. All right. So since you have a pie, what do you have? You have an angle. You have the radius of your pie, and you have the arc that is created here. The arc here is not a straight line. It is tilted a little bit. It is curved a little bit. This is an arc. So let us label this. This is my radius, which let us denote it by R. The radius for the vector or for your ray is going to be the same here and here. Remember that if you keep rotating this arrow, you are creating a circle. All right. Here, if you just continue this, you're going to create a circle. Any circle has a radius, all right? Any circle has its radius. So this is my piece of pie, which if I continue this arrow, this ray, one full rotation, I get a circle. So the length of the arrow is the radius, which we denoted by R. Now, take a look at this part. This guy, this piece is not a straight line. This is just an arc. So now let us go back to the definition of 1 radian. 1 radian is the measure of the angle that you have when the arc length, if you measure this arc, this piece here, it's exactly equal to the radius. So we can write it this way. R is equal to the arc length. The arc length, let us denote it by S. The length or the measurement of the arc is denoted by S. The measurement, the length of this arc is denoted by S. R is equal to S. Let me use the same color for R that I did before. That's how we define 1 radian. So 1 radian, it happens when this radius is equal to the arc length. Very well. So we define 1 radian is the measurement of this angle when the radius is equal to the length of the arc. So R is the radius, the length of the arc is denoted by S. So when R is equal to S, we have 1 radian. Well, so I expect you to ask, what about if I want to find the rest of the radians? This time, you're going to just do the division. You're going to write theta equals to S divided by R, or theta is equal to the arc length divided by the radius. So this is the definition of radian. So to calculate the radian, you just take the arc length and divide it by the radius itself. Arc length is denoted by S. Very good. Now, 1 degree. 1 degree is defined as, so to define 1 degree, you write down 1 degree is equal to, here you have 180 degrees, 180 degrees divided by, you're going to take whatever your angle is, pi times radian. So 1 radian is defined as the arc length divided by the radius, and 1 degree is equal to 180 degrees divided by pi radian. Let's go over a couple of examples so you feel comfortable about this. Example. Find the degree measurement of, well, the very first one, suppose you have pi radian. Suppose theta is given to you as pi. B, suppose your theta is given to you as pi over 3 radian. Suppose your theta is given as pi over 2 radian. So these measurements are already given to you, and the question says, hey, convert them into the degree measurement. What is pi radian? What is pi over 3 radian? What is pi over 2 radian? You can continue this process. How do I convert the radian into degrees? So what are you going to do? You're going to, where is my, oh, it's here. We're going to take each of these measurements and multiply them by 180 degrees over pi radian. To convert the radian into the degree multiplied by 180 degrees divided by pi radian. So let us do that for each of these. The first one, we take pi and multiply by 180 degrees divided by pi radian. So I have pi radian. I'm going to copy this down. Pi radian times 180 degrees. Okay, not that bad. Divided by pi radian. So let's see what's happening here. Guys, you have common factors. You have pi and pi, they cancel out. You have the unit, radian and radian, they cancel out. What's left? 180 degrees. So pi radian is 180 degrees. How do I visualize that? Well, the visualization is not that hard. The angle pi is going to be just right here. So this is my pi radian for 180 degrees. Theta is pi in radian. Radian or theta is 180 degrees. A ray started at initial position, rotated counterclockwise, and stopped at terminal position. It created 180 degrees or pi radian. Let's take a look at second example. What is pi third radian? How do we recognize that? Well, it says to convert the radian into the degree multiplied by 180 degrees over pi radian. So whatever my angle is, I'm going to copy this down. Pi thirds radian times the exact same fraction, 180 degrees divided by pi radian. Okay, get rid of common factors. Pi and pi, radian and radian. What's left? Well, 180 degrees divided by 3 is left, which is 60 degrees. You see, by converting them into degrees, you can easily visualize this. So my initial position, let's just write here, right? And then I start rotating this pi third radian or 60 degrees. 60 degrees. This is my theta, which is pi over 3 radian. Okay, what about pi over 2 radian? The same process. We take pi over 2 radian and we multiply that by 180 degrees divided by pi radian. Pi over 2 radian times 180 degrees divided by pi radian. Get rid of the common factors. One of them is pi, the other one is the radian. So what do you get? You get 180 degrees divided by 2, which we all know is 90 degrees. Well, this guy is just located on the positive part of y-axis. You started from the initial position, the standard initial position, 0 degrees, and we rotate this guy 90 degrees or pi over 2. The terminal position is here. So theta is pi over 2 radian or 90 degrees.